Okay, well, let's go down to the next question. So this says plate motion, and so this is when we're going to come along here and click on seafloor ages. Okay, so you'll learn as we go along that we're able to actually date the sea floor from dating, geological dating, but also due to magnetic reversals. So the Earth magnetic field is flipped, and that's recorded in these rocks, which you'll learn more about. And so let's go here to this ridge between Africa on the right and South America on the west. This is where the ocean's splitting apart, and you can see this is where there's got these red lines. Well, this red means that the ocean is 0 to 10 million years old, so it's very young. And as you move away, obviously you're getting to older and older oceanic crust, and as you hit South America here, you've got the oldest ocean crust, not oldest rocks in the whole world. The oldest rocks in the whole world are on the continents. So the oldest ocean crust here is close to South America, and it's this light purple. Yeah. Well, actually, let's just zoom in. Maybe, anyway, I don't think this purple, I'm not 100% sure. But you'll see from your assignment, when you look at it, there's actually, oh here, you've got darker purples in the north of the Atlantic, which is this 180 million years, and lighter purples. I think this lighter purple's actually got to do with topography. So darker purple up here is 180 million years in the north of the Atlantic, and down here, ignore this light purple, you're actually dealing with this blue, which is here like 140 million years. So you can see this ocean here in the south is actually younger than this ocean in the north. And you can drag all around the world to see different ages, and you can see how complicated it is here around Indonesia and the Philippines. So you're going to look at this. It says how many years do each of these time bars represent, what's the age of the ocean, the oldest age. It talks about the northern basin and the southern, the northern Atlantic Ocean and the southern Atlantic Ocean. So you'll answer those questions there. And then the last question here says, sketch a north-facing cross-section along 10 degrees latitude from Africa westward to the middle of the Pacific, plate-wise. This could be from the African plate across South America and the Nazca plate, ending in the middle of the Pacific Ocean. You're crossing 3 plate boundaries. Use Google Earth imagery and layers to give the necessary details to include the labels. Okay, so what it's actually saying is that you have to draw a profile on the map. Let's get it north. Going, and you can see I've already got one here. Let's just make sure it's clicked properly. Sorry, let me take off the ages. Oh, sorry, I'm causing trouble. You can adjust all of these to see better. Here's my profile. I think it's this one. So it says going from Africa, north facing. So we're going from Africa to South America and over the Nazca plate into the middle of the Pacific plate. So you can see here, this is the Pacific plate. Have I got that right? Into the Pacific Ocean, yeah. It says here, across South America, into the middle of the Pacific plate. So you're literally going to use this path option and click along the way. And then you're going to right click and do the show elevation profile again. You're going to make sure it's showing you everything. I'm going to just take off these earthquakes so that I can see it better. And the big thing is to make sure you know which direction this profile is going. So let's just see. Okay, so it doesn't matter if you've done it the other way around. Oh, sorry. So I've done mine the other way around. This should actually be swapped, because what happens is if I do it the way that it says, then my profile is a bit confusing to look at. Show elevation profile, because you can see here we're going on the earth from west to east, but if I drag on my profile, you can see this profile is going from east to west, which is you can have, but it's a bit confusing. So your choice which one you want to do. I went and actually started clicking in the west here and moved towards Africa, which is what gives me this profile that I'll show you. It's a bit easier to understand because when I drag, you can see it's going from the Pacific over South America, over the Mid-Atlantic Ridge, and into Africa. And so that's the whole point here is, and to be honest, not this week, the next week, you're actually going to submit this profile for marks. So if you didn't get around to it, you get a chance to look at it again. The main thing is I need you to draw labels on it. So where is the seafloor? What significant topographic features can you see in the continent seafloor? Indicate earthquake hypercenter, so where's shallow, where's deep, where are volcanoes, plate name and boundary locations, approximate vertical horizontal scale, so I do want you to actually include a y-axis and x-axis, arrows indicating plate motion. So what plates are moving in what direction. So let's move from the west here. You can see as I'm going along here, this small little rise here, sorry it's hard to see with this numbers, that small little rise over there is actually this mid-ocean ridge here between the Pacific plate and the Nazca plate. And as we keep going along, we know that this here is our trench off of the west coast of South America. This over here is this super high mountain range of the Andes, and then this flatter region is the plains of South America. Then we hit the edge of the continent and we go back into the ocean, and you can see this region here is this mid-ocean ridge. It's a lot bigger ridge than this one here between the Nazca and the Pacific plate, and then we come here up onto Africa. And so here at this ridge you've got plates moving apart from each other, as well as this ridge here. And at the subduction zone you've got this western oceanic plate going from west to east and going underneath South America here, and South America is going from east to west, and so they're colliding with each other. So that was the assignment. Sorry this video is so long, but I hope it was helpful.